Hello, welcome to Berkshire Guitar Amplifier Repairs in Reading, England. It's -3 today and has been for the last 3 or 4 days, so it's pretty cold and miserable, just coming up to Christmas. And in the workshop we've got a Marshall 1930 model 10 watt combo. So this amp is only 10 watts. It uses a couple of ECL86s on the output stage, not EL84s. And this one's come in for a good look over and a refurbishment to kind of bring it up to spec. So let's have a little look at this fairly rare amp. So just a quick look top side, 4 inputs, a standard clean channel and then a tremolo channel here. It achieves the tremolo quite cleverly actually, with just one ECC83 does some amplification and half of it does the tremolo, but these tremolos are a little bit iffy on some of these amps. Anyway, we'll see if that works, and that's pretty much all it is really. Off, on, standby, tremolo, very simple basic amp really. You couldn't gig with this, but it'd be quite nice for home use. Anyway, let's get the back cover off and have a look inside. And here we are on the inside. As you can see, a fairly simple tag board construction and not a lot of components. What you see is the total component complement, apart from a dual smoothing cap. This is an interesting amp in that it takes ECL86 valves, 2 of them, instead of the usual ECC83s and EL84s. So the EL86 is effectively 2 valves in one. It's got one stage of a triode like a ECC83, so think of it as half an ECC83 preamplifier linked with a pentode, which is the EL84 effectively. So think of that as like a half an ECC83 and an EL84 in one envelope. So that's quite a useful valve, as you can imagine. In one valve you get 2 stages of gain, or 1 stage of preamp gain and a sort of little power amp. So just looking along this, things I might want to think about changing. These diodes are the rectifier diodes and they're quite old. I think I'll upgrade those for a couple of 1N4007s. This is all okay. I will change this smoothing cap. It's quite old, 50 years old, probably perfectly alright, but we'll change it. This is probably a cathode bypass resistor and capacitor for the push-pull stages of the ECL86s, and this is the cathode resistor, and as you can see, that cathode resistor is quite sort of I don't think it's supposed to be like that, bubbled and horrible. So I think we'll be changing that, and we'll definitely be changing that bypass capacitor. Everything else is probably, I'll check these resistor values, but I expect they're all okay. I don't want to do too much work on this. And then these 3 caps here are doing the phase shifting for the tremolo oscillator, because this only has 3 valves, this amp, and it's also got tremolo, so that's quite amazing to get all that into 3 valves. So that's doing that, and I will change this electrolytic capacitor here. I'll service all the pots. They are very bad. This amp has obviously been lying around for a long time. I've already cleaned up the front panel a little bit. A little look along there. The other valve is this ECC83. So there's an ECC83 which is doing 1 stage of gain, and the other stage is doing the tremolo, and then the 2 power valves go here, or the 2 ECL86s go there. Not much more to say. There's the smoothing cap, look, dual stage. I probably won't change that, it looks okay. Can't see any evidence of leaking or bulging. I will have a look at that though. That's about it really. Just needs a good old service. It's been lying around a long time unused. Let's have a little look at the schematic, which I managed to get hold of. So here we go. Let's just have a quick look and follow this through. So input jacks here, look. Volume control. tone control, just a simple capacitor to ground look. And then here's the input coming into here, and so here are the other inputs here coming in. So we've got two volume controls. That's the yes, here we go. So here we go. There's one set of inputs there. Look, with these volume controls and tone controls, and another set of inputs here with these volume controls and tone controls. Now that of course is the tremolo channel. There we go. So they go into here. They get mixed together, I expect. Yes. So mixed here. Look, and here the 470k mix the resistors and a 1 meg to ground. So you get the combined signal here. One stage of amplification on that ECC83, and then the second stage is the tremolo, and that's done via this phase shifting network here, which effectively takes the output of this valve, phase shifts it enough to make it approximately 180 degrees out of phase to bring it back into here to cause an oscillation. So this is an oscillation loop here. These are interesting. Don't know what those are. Well, I know what they are. They're two presets by the looks of it. I don't think they're there. I don't think they're in the situation. Maybe it's adjust on test or something to get the oscillation to work. Anyway, there's that 25 microfarad bypass capacitor, which is almost certainly this one here. Can't see any presets there, so I think there must be adjust on test. Now what else have we got? So come out of here and into now our so the preamp side of these ECL86s. Remember, this is one valve and this is another valve. So these two preamp sides, effectively that's one ECC83, is being used as a phase splitter. Split the signal into opposite phases to drive the what you might call the EL84 part of the valve here, which is fairly standard, and that just drives the output transformer and goes to the output. The rest is just mains coming in, rectification, 32 microfarads, 32 microfarads, that's this capacitor here, doing some smoothing. Oh, and here's the cathode bypass capacitor. Look, here are the cathodes of the, let's call them EL84s, going down to ground via that 125 ohm resistor, and that is bypassed to AC by this 25 microfarad capacitor across it. Actually, as it happens, on the actual circuit we've got 50 microfarads, and I've measured that resistor and it is 125 ohms, but certainly don't like the look of it. I'm definitely going to take that out and have a look at that and then replace that. It looks like it's got very hot at one point. So there you go. Hope you enjoyed that little walk around of the amplifier. So what we're going to do now is get stuck in and start changing some of these capacitors out. Right, there's the cap that came out, 33 microfarads at 450 volts. It's probably perfectly right. It doesn't show any sign of bulging particularly, but it's quite old, so I think we'll change that for this nice F&T 33 microfarads at 500 volts. And to do that, this is the way I do it, and I'm sure some people will wince at this, but anyway, that's tough because this is how I do it. I use existing wires of the component that was in there, and so effectively take this and just bend that round like that, make a nice secure anchor, and then crimp it onto there. And now we can solder that on there, and that'll be a perfectly good joint. I know some people like to put the components back into the original tag board. I often, there's so many different ways of doing things. There's no right or wrong way, to be honest with you. I often find with these tag boards you just can't get the component in, or there's something connected underneath here. There's a wire underneath there linking there to there, or linking that to there underneath the tag board, and it can make it just a little bit difficult sometimes. So I find, especially with a bit of flux, you probably saw me put some flux on there, that is an absolutely perfect joint, and that's not going anywhere for the next 50 years, so I'm happy with that. If I was working on a NASA spacecraft or something, well, first of all, I wouldn't do that. I haven't got the skill or the temperament to do it. You need to be a particular sort of person to do that kind of very exacting wireman's work. That's a real skill, that, if any people are watching and they are wiremen, wirewomen, you'll know what I mean. It's you have to be ultra pernickety, same as military stuff, you know. All has to be very absolutely done by the book, regardless of whether it's in a critical position or not. That would bore me to tears doing that, but I do admire the people who do that. I used to hire wire people who were very good at that, and they were a joy to watch, the way they would make up cable looms and that sort of thing. Wonderful. But that is good enough for our purposes, and I promise you those joints are excellent and will last easily as long as the existing ones have done. So now I'm going to have a little look at this setup here. To do that, and just literally cut this capacitor out, look, and just get rid of it. This is definitely one I want to replace. God, that probably completely dried up that 50 microfarads at 25 volts. And so whilst I'm here, I want to take out this resistor. Notice I cut them off, leaving enough of the lead that I can then bend up and use. Now, what's going on here? Yes, a right flippin' mess, this, isn't it? Look at this. This has really got very hot at some point, and surprised that's still holding its value, which it seems to be doing. It's supposed to be 125 ohms, I think. Have a little look. Look at that. That's held its value, even through thick and thin. 117 ohms. So I'm going to replace that. God alone knows what with. I certainly haven't got a 125 ohm resistor in stock, so I'm going to have a think about that. Okay, the plan is to put two 270 ohm resistors in parallel, giving 135 ohms, which is perfectly alright for our application here. And the way I would do that would be to do this, to put that one in parallel with the one beneath it like this. Solder that there and there, and now I've got my 125 ohm resistor here. Probably crimped on enough for us to actually read what the value of that final resistor is. Should be 135 ohms. It's one. Oh, we're lucky. These resistors are slightly out of tolerance. So, and then they've gone the right way for us. So 127 ohms versus 125 ohms is a real result. So I'm just going to solder that up now, and then we'll put that in. Then we can put the capacitor in. There we go. There's our little parallel resistor arrangement. And we just cut off this excess here. And there we have our nice 127 ohm 4 watt resistor, which is more than enough. The existing one was probably only 1 watt or 2 at the most. So that's going to go in there like that. And I'm going to find myself a 50 microfarads. I'll probably find myself a 47 microfarads at 50 volts to put in there. Interesting that the schematic calls for 25 microfarads. It doesn't matter. All this will do is give a little bit more, an unnoticeable amount more of bass response. So it's perfectly okay to upgrade that capacitor to a larger microfarad If you went down in value, then fewer of the high frequencies would, well, fewer of the low frequencies would get through, and so you start to lose base response. So as you took that down to 10 microfarads, 4.7 microfarads, 1 microfarad, you lose more and more of the base response of the amp, and it would become more trebly. There we go. It's actually I quite like this way of doing it. It doesn't disturb all the tag strip and all the existing soldering. You can imagine if I had to try and cram that resistor into this tag strip with this wire here going in as well, and sometimes here's a good example. Look, perfect example of that. 3 components going into this one tag, and if I had to change that capacitor, I've got to somehow force the new capacitor tag down in there somehow. Of course, it's all doable. I find it really fiddly and difficult to do though, and as I say, it does disturb all the existing soldering. But you know, everyone has their own different ways of doing things. So long as you end up with a decent job at the end of it, that's all that really matters. Right, so there we go. So there's our 125 ohm power resistor replaced. Notice I put my finger on top of I'm just trimming off the excess here, but instead of just going clip, and that piece will just fly off somewhere into the amp. It's always good practice. I just put my finger on top there, and now I've got that piece here. Well, you can see it actually there in the cutters, and now I can just chuck it away from the amp. Just a little good practice that. Right, next thing, let's see if we can find ourselves something like a 50 microfarads at 25 volts. You don't normally have to use flux in most of the solder joints you do. It's just that, of course, with these 50-60-year-old amps, the existing wires are not in terribly good shape, and the flux just takes any corrosion off there and makes for a good joint. Done there. Redo that section. Just crimp that on there like that. I've put 100 microfarad in there. Just fun enough, didn't have a 50, and 100 is fine. Just gives a little bit more base response, so nothing lost really. So just put a little bit of flux on there. You don't normally need to use flux in your soldering. It's just that with these older amps, you can get a bit of corrosion on these existing wiring, and the flux just helps to remove that. Good. Another little bit of flux on here. Lovely. So that is that resistor and capacitor in. Right, that's that resistor and capacitor in, that capacitor done, good. There's this one over here that we want to do, and that is 25 microfarads at 25 volts. So we'll get one of those and chop it out first of all. Another good example here, you've got 3 wires going onto one tag there and 3 wires going onto that tag there. Just makes it quite difficult to get another one on there, or those eyelet boards, you know, shove them down the eyelets. So anyway, there we go, and we're after a, this is 25 microfarads, 25 volts. Yeah, I'll go and grab one of those. Put a 22 microfarad in there, that won't make any difference whatsoever to anything. Yeah, just notice I put that in the wrong way. Also, you can't be too careful. Yeah, amazing. Yeah, it's annoying how that can happen. Doesn't matter, I like to leave mistakes in. It makes it's more authentic. It's all very well watching the genius tech never make a mistake and everything going swimmingly, but I promise you, in this business you'll make mistake after mistake after mistake. Some of them pretty damn stupid. I've been doing this for years and still make the most ridiculous mistakes. It is actually compounded by making the video, because you've got half an eye on the video you're making. But I still do make silly mistakes, which is why I try to kind of double check everything all the time. Particularly these electrolytic capacitors, you have to make sure you put them in the right way. Negative down, that's negative down, correct. Right, that's all our capacitors done. The next thing to do is to turn the amp on again and just make sure it works. Look, I'm holding the tag here to make sure that doesn't fly off anywhere. Right, there we go. So yeah, let's turn it on and see if it works. Now, just before I turn it on, the customer has supplied 2 new Edicron ECL86s, so we're going to put those in. And also, before I do that, I'm just going to give the valve bases a little service too with some deoxit. Here's the preamp tube. It's a Pinnacle, probably original, ECC83. Yeah, the contacts are very corroded, look. So I'm going to clean that up. In fact, I'm going to put it on my valve tester first. There's no point in cleaning this up if it's completely worn. So, slight diversion. Let's see if this valve's any good. So here's the preamp valve on my orange valve tester. the test is coming to an end. These numbers gradually count down, then it'll give us 2 LEDs on, showing us the gain of each side of the ECC83. Okay, they're quite close look, they're fairly closely matched, 7 and an 8. I think the flashing might even mean 7.5. And it's come up good, so that pinnacle valve is perfectly alright. So we're going to clean that up now and clean up its valve base and pop that one back in. Okay, the way I clean these valves is just to get a piece of very fine emery cloth, extremely fine this, and I put a bit of deoxit on there, and then just go around the outside of the pins like this, and then I shall try to do as much of the inside as I can, like so. Like that really, and that just cleans them up nicely. And then I would normally just put a squirt of deoxit down the actual valve base, like so. And then we just pop the valve back in. That's good. Now, we probably don't need to clean these. These are new valves, but although they're new, they are new old stock, and they've been hanging around quite a long time. I don't think these are made anymore, could be wrong. So these are probably 50 years old. Don't forget, it doesn't matter how old a valve is, it's how much use it's had. So you can have a 50-year-old valve that's been in its box for 50 years, and yeah, it's pretty much as good as new. Or you can have a 2-year-old valve which has been completely hammered and is no good at all. So I notice the pins are bent on this one, don't know why, straight out the box, but that pin there is not right, and neither is this one. Quite badly bent those, interesting. Let's just check the other one. Yep, they're all okay. Right, so again, a little bit of deoxit down the valve base. That wipe off the surplus. Deoxit doesn't really evaporate, so it's good just to wipe off any surplus you see. And that's gone in there. Pin's still not quite straight on this one. There we go, let's try that. Yep, there we go. Might as well pop these on as well. And now we're ready to connect up a speaker and power it up. So let's do that next. Right, power's on. Just waiting for it to warm up. Sounds good. The pot's not very good. Put a bit of, whilst I can see it, put a bit of deoxit in there. Okay. What on earth was that? Ugh. Horrible racket that was. That's not very good. It sounds quite nice. Right, let's just try the tremolo channel. Ah, okay. Now we've got a bit of a problem here. This is very iffy in that socket. Not a lot better in that one. Nasty. Okay, that's probably what happened. That horrible noise we heard. Right, that's quite surprising actually after cleaning those valves and the bases. So I think I'm just going to have a little eyeball down in there and see if those pins need retensioning. Okay, the socket seemed fairly well tensioned in there, so I used a little trick by taking a cocktail stick, dipping that in a bit of deoxit and then going into each of the pins and twizzling it around, and quite a lot of dirt came out actually, and that has you know, made them all a lot better, so that's good. Let's now try the tremolo channel. Now there's a foot switch on this here. There we go. Oh, that's interesting. The tremolo started and stopped. That's no tremolo, and when I press this, look, then the oscillations die away. So we've got a problem with the tremolo on this. That seems to be alright now. Might just have been at very, very slow speed, it can't cope with the oscillation. Yes, as the speed is turned down, the oscillation of the oscillator section stops. Not sure why that is, so I need to investigate that. Right, what I've found is that upgrading this 25 microfarad here to a 47 microfarad gives the speed a bit more range. So let me just show you that. I've got another 25 microfarad clipped across it. So now we're on, like, that's full speed. That's at half. And you can still hear it. But if you listen, it doesn't really do much speed-wise from there down to 0. So have a listen. So that's another quarter turn. And that's the same speed as that. Then we go to 0. So there's not much range on that pot, so I think I might adjust that so that that range is spread more evenly across the range of the pot, because it's not really doing very much down there. Probably not terribly good design. So let's see what value that pot is, and probably just add a fixed resistor there. Okay, what I'm finding is there's limitations of the circuit design. Basically it's a 1 meg pot in there. And I've got my resistance decade box here, which I can set up. So with 1 meg in circuit, look, this is the sort of speed we get. And with a short circuit, we get this fast speed. So in my view, the limits of the speed on this, the way it's designed, is this down to this. I think we're going to have to live with that. We can get slower, look, I can go to 1.5 meg, and we get a bit slower. But of course, to make that happen, I'd have to put a 500k resistor in series, which means the fastest we can get is 500k, which is this, which is nice, but not as shimmery as this. So I think I'm going to live with that fast one, and this slow one. So in other words, just put this back together with the 1 meg pot as it is. Of course, the other thing is we can change these capacitors here for make them 0.2 instead of 0.1. That would slow everything down to half the speed, so we get a very nice slow tremolo, but the fast one wouldn't be so good, you see. So it's a question of getting the range on this. Right, there's the fast and the slow. Interesting, something about this pot, it's not behaving the same as when I had the resistors in series. So that's about 1 meg there. Well, that calls for a 1 meg pot on the circuit. Speed is 1 meg there, and I'm pretty sure I measured about 1 meg on that. So what is this pot? It is 2.2 meg, maybe it's a 2.2 meg pot. Should be 1 meg, which is why we're getting this problem. So that's why we're getting that. With 2.2 meg, it's trying to oscillate very slowly and can't. Okay, to fix this problem, I've put a 2.2 meg resistor across the pot. So the maximum value the pot can get to now is about 1 meg, which is what we wanted. So here's the high speed, and here's the low speed, which is about what we were getting on our resistance decade box. And the sacrifice is there's not much range between there and mid. Doesn't do a lot between there and there. But you can set the speed you want, and I don't think we get much lower than that minimum speed. Right, I thought I'd just try a 4.7 meg resistor across there, and that's worked quite well actually. So here's the fast, and here's the slow, which is nice. There's not much range between here and here, but that doesn't matter as long as you can set the speed you want. So I'm going to go with a 4.7 meg there, and by a bizarre coincidence I literally had to stop testing this because the phone rang, and it was Dave from Marshall on another matter, and I told him I was working on this. He said, oh, he's worked on loads of these, the tremolos are terrible on them, and they barely work. So I thought, oh, that's interesting. Okay. That's the first thing he said. So that's amazing. So he said a lot of the tremolos on these early amps are very kind of sensitive and iffy. Even changing the valve for a different make can cause them to stop working. Right, so I'm going to make that nice. I'll just unplug it. So I'm going to make that nice, and I'm going to change those two diodes there. Yeah, they're probably gone for another 50 years, but I'll do that. And then I think I'm happy with this amp. We're going to give it a final test, but I think we're good. So there we go, 2 new diodes in, and a bit of a tidier arrangement on the extra resistor there, and that all now works perfectly. So I think we're done with this amp. We can put it back in the case and call it a day. Well, there you go. Hope you enjoyed that one. I quite enjoyed working on this. I've never worked on one of these before, and you can see how the time runs away, can't you? You know, we got involved in that tremolo problem for quite a while, and the time just mounts up on these amps really. Anyway, I really liked working on this. It's a funny little amp with just 10 watts of power. I suppose it gives quite a driven tone, and quite rare to have those ECL86s in an amp as well. I'm not even sure I've ever worked on an amp with ECL86s in the output stage like that, so this is a first for me. Anyway, thanks as always for watching, and I'll see you on the next video.